quickly, because of Joey, we have about 5 minutes, so the video will probably be 5 to 10 minutes long. Now look at this. If the deviation from here is -1, and the deviation, Alex, I'll send you out of this class, and the deviation from here is +1. If we had all the deviations, because we're talking about the minimum deviation, if you just add directly, you get a 0, which means, oh, there's no deviation. Actually, there is. Do you understand that? Yeah. So we always apply square to it. So we square the deviations, and we say, oh, the total deviation is actually 1 + 1, because it's -1 square minus 1 square. So the deviation is 2. Do you understand? If this has a deviation of -3, and this has a deviation of +3, if you are not careful, you will say, oh, sum of all the deviation, because it's easy to think that way, that, oh, this has deviation of this, deviation of this, let me see, the minimum deviation should be, what is the minimum when I had everything together? When you had everything together, you get a 0, which means you are interpreting it as this, which is not the case. So what we normally do is to square the deviations. So which means in this case, we're going to say +9 + 9. So the total deviation is going to be 20. You will now focus on the square of this deviation. The smallest sum of this deviation tells you the closest to the exact point that you need. Am I making sense? Because if this line gives you a deviation of 20, another line gives you the total deviation of 5, it means that is closer, provided there are the same 4 points.
Oh, yes.
Am I making sense? Then another one gives you 0.1. Oh, that is more accurate. And you will only get a perfect one when the total deviation is 0, which means none of them has left the line. Okay? So our main focus is to make sure that the sum of these di's, when you square them, is as small as possible. Am I making sense?
Yes.
And each deviation, if you agree with me, each d will actually be the point on the line minus the y value here. Hello?
Yeah.
The y value here is y1.
Yeah.
The point on this line is just ax plus b. Are you with me?
Yeah.
Every point has its own ax plus b. So on this line, I'm going to have y1 minus ax plus b.
Oh.
Okay? Similarly, for my second deviation, d2, it's going to be, oh, this y2 minus this point on this line. Then we just put a substrate, 1 and 2, so that we know that this is with respect to x1, with respect to x2. Remember, this point x1 here will be substituted to get this y. It's not the same as the y1 that I'm talking about. Again, y1 is not this in this case. Okay, this is wrong. This is wrong. Are you with me?
Yes.
Let me go over that again. For this deviation is the gap between the y value and the value you get when you substitute x1 into the equation of this line. Okay? Similarly, when you substitute x2, it is the gap between y2, which is here, and the value you get when x2 touches the line. The line is this. So every deviation is going to look like this. Similarly, I'm going to have a d3 that is going to be the gap between y3 and ax3 plus b. Am I making sense?
Yeah.
So we are now interested in squaring all this and finding the minimum. Okay? And that is where the formula will come out from. Let me see if I can. I need 5 minutes. Can you guys wait 5 minutes?
Yeah.
Because I don't want to go over this tomorrow. I just want us to apply it tomorrow. Okay, quickly. The main thing has been explained. Also, before I proceed, I need you to recall something. If you have a quadratic function, ax squared plus bx plus c, when is it minimum? When do you get minimum points? Quickly.
A is.
When-
Greater than 0.
I'm asking you like a math student. Yes, quickly. When A is
Greater than 0.
greater than 0. When the coefficient of the variable, the leading coefficient, is greater than 0. You might come across a quadratic equation that looks like this. PR squared plus QR plus T is equal to 0. In this case, the variable is R. So when is this going to be minimum?
P is greater
When
than
P is
0.
greater than 0. The vertex is what? The x value at the vertex is what? Remember the value we have, the vertex we have x comma y, is that not? What is the value of x at the vertex for this function? X is equal to what? Negative b over
2A. 2A.
2a. Thank you. The vertex will be what here?
Negative Q.
What is the variable first?
R.
R equals.
Negative Q over 2.
I'm going to apply this on the way. That's why I want you to remember what we did. That's going to look confusing. But do you mind, or do you want me to do this tomorrow instead?
Fine. We do it now. Better.
Class, vote quickly. I don't want it to look like I'm wasting some people's time.
Do it now. Do it now.
You don't mind now, raise your hand. Don't raise your hand because others are raising their hands, please. No one can force you to do what you don't want to do. Okay, thank you. Just a few more moments. All right, now having done this, so we say that, let's write it. We need a more precise line, da, da, da. I wanted to write a preamble there. Okay. This line, okay, I can write the preamble later. Let's just go into the details. Let's, our deviation, okay, which is going to be summation of all the di's. Remember, there are endpoints. Okay. The idea is to minimize d, to make sure we get the minimum d. Some of the deviation that I just demonstrated is what I mean by this. Okay? If your d can be smallest, it means that is a more precise line. Understand? This is going to be the addition. Remember this format? yi minus axi plus b. And we are going to square the deviations.
Okay.
Because if you don't square it, you might end up getting 0 and it might be misinterpreted.
Okay.
Okay? So quickly, the d is going to be, because this contains I, how about we bring all the I groups together? So this can be yi minus axi in the brackets, and then plus b can be on its own. Do you agree? Oh yes, minus b, my bad. Okay? In this case now, we can now say, okay, because this looks complicated, because I'm going to open this bracket, let's introduce maybe wi to be equal to yi minus axi. So that our d can be written in a, easier form, which will be what? wi minus b all squared. Okay? Then we can square, we can open the bracket. This will be addition, I from 1 to n, we have quadratic. wi squared minus 2wib plus b squared. We have done summation in topic 1. Remember, your sigma can go in, and the constants can come out of the sigma. Now, which one will be the constant, w or b? B, because it doesn't contain I. Hello? Okay, so if you open that, you're going to get your d to be, watch this. Right? Minus 2b. Yes? Then plus, I'm not removing this yet, there's a reason. What is the summation of b squared? I from 1 to n. Nope. 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 Close. Not so close. Sorry. Summation of all b squared. When n is 1, you get b squared. When n is 2, you get b squared. When n is 3,
Yeah,
nb squared. Thank you. nb squared. So you have w squared, 2b, wi, then this will be nb squared. Now this looks like quadratic function with variable b. So that you have nb squared. So n is the first coefficient. Minus 2. I'm going to put the sigma first so that it looks like quadratic. Can you see that?
Yeah.
Then plus, this will be the constant term now. Miss Kadina, are you lost?
A little bit.
A little bit, okay. You can wait behind, I will rush through this first. I'm happy to re-explain it. So this is the quadratic function. So d is a quadratic function, just like y was a quadratic function. Okay? The variable is x. So when we are talking about at the minimum point, we always refer to the value of x at that point, right?
Yeah.
Here we'll be referring to the value of what? B at the minimum point. Okay? That's why I wrote that first. D will be minimum or minimized. Meaning, okay, I mean something. Minimized when what happens? When b is equal to negative b over a, right? What's our b here?
-2.
This one.
Yes. Exactly. Yes.
And our a is
And
n. Oh, I forgot something. How do we know it is minimum?
because
It could have been
n
maximum.
can be negative
N can be negative
or 0.
or 0.
Oh, yeah.
So b will be minimized since n is greater than 0. If,
B is equal to
are you following?
Yeah.
So that will be, negative b will be negative this, right?
Yeah.
So I'm just going to write negative 2 summation of wi, we put all the I something later, divided by 2n. So they're going to cancel. So you're going to end up having that divided by n. That looks like n bar. That's like w bar, right?
Oh.
Wait a minute. We're not going to write that w bar because there's nothing like w here. It would have been nice to stop here, right? And just write w bar. But there's nothing like w. So we put it back. So we say sigma. Okay, I go here. So we say b will be equal to shoot. What's our w? yi minus axi divided by n. So we separate. If we separate, it's going to be sigma yi a sigma xi everything over n.
Yeah.
Now it's looking more familiar. So our b will be sigma yi over n. Now this makes sense.
Yeah.
A sigma xi over n.
Yeah.
So what is this? Y bar. There's no I in bar.
All right. Yeah.
Minus what?
Minus
So which means the line we are looking for, the line y is equal to ax plus b, can be computed when we know the values of a and b. And this is how you get the value of b. But then there's still one unknown, right? The value of a. To get the value of a, we substitute b back in here. And we're going to follow the same process. And we're going to come up with a quadratic function. And we are going to minimize whatever variable we discover. And a will be revealed. Quickly. Put b into, let's call this equation 1. Again, you don't need this. I just need you to see the way we reason improves. Because it's going to come in handy, one way or the other. You don't need to know this. Put this into equation 1. Equation 1 says, I'm sorry, Joey, if it is. You want someone to take
It's
over?
okay.
I'm recording.
Are you sure?
Yeah.
It's not a bad.
Okay, quickly, because of time. Don't worry, SL, I know this is your break time. Don't worry, I'll bribe you with chocolate tomorrow. No HL.
Fine.
HL will get it. Okay, so quickly. Our B will be y bar minus ax bar. Do you agree?
Yeah.
So I put this bracket back and I close it all square. So you can see something. If you open that bracket, we have sigma. I'm going to remove all the I something, okay? Just to make life easier for now. Minus y bar plus ax bar. Is that not?
Yes.
All squared. Even though we might not know what to do, but we can see I, bar bar. Okay, there is y bar, there is x bar. Let's bring, families together. And even the x have a's, right? Okay, let's group them together. They look like they know each other from somewhere. So we can have y bar minus y minus y bar, then minus a xi minus x bar. Do you agree?
Yeah.
So this could be one group, and then everything is inside the square. Again, remember your square. If you do a squared plus a plus b all squared, what does that give you? A squared, 2ab. So our a is this, and our b is everything here. So the square will be sigma, yes, y I minus y bar squared minus 2a, thank you, 2a yi minus y bar xi minus x bar plus a squared xi x bar all squared. Can you see that? Then we open the bracket again, and you can see a quadratic in what variable?
A.
In A. Can you see that?
Yeah.
So if you open the bracket, you get sigma yi minus y bar squared 2a. So maybe I write the a separately so it's easier. Okay, let's write first sigma first. Y bar yi minus y bar xi minus x bar. What again? Plus a squared sigma xi minus x bar squared, something like this. Okay? So to make it look quadratic, we have, I like to write the coefficient first so it's easy to see. So then you put it in brackets, please. So you have sigma xi x bar squared a squared, so that's the coefficient. Okay, I'm so sorry for those that want to leave now, I'm so sorry. Then you have what for the middle term?
Minus 2.
Minus 2 sigma. Let's arrange this in alphabetical order.
Yeah.
So we have xi minus x bar, yi y bar, and everything now is the coefficient of a. Then the constant term, summation yi minus y bar all squared, which is quadratic. How do we know this will give minimum also?
Because that
cannot be negative. Okay? Which is quadratic. Which is a quadratic function in A. Okay? D is minimized. Again, this is going to be minimized when, okay? This is going to be minimized since that coefficient, like we said, the first coefficient xi minus x bar, right? All squared must be greater than 0. When, yes, what is that value? When a, right, is equal to, you see, you have gotten b, this is how a comes out. So again, minus 2, I'm going to write that summary. It's going to be minus this, which means the minus will be removed, divided by 2a, which is twice this. Then the 2 will cancel, and you are now left with this divided by that. And that is the formula for the least square line of regression.
The sigma you cannot cancel.
You cannot. So it's going to look like this. Minus
Minus
2 sigma xi x bar yi y bar everything over 2 sigma xi x bar all squared. So which means what?
Miss out on negative.
I miss out a negative, thank you. Minus minus, something like that. So that's, and the 2 will be gone as well.
Yeah, so it's plus.
So it's just going to be sigma xi minus x bar yi minus y bar, everything over summation xi minus x bar all squared. And this is how to find. So if you are going to do it, if you are supposed to do it manually, maybe somewhere in the future, all you have to do is create that table. Remember the table we did in the past? You create that table, you find out all this. So first of all, please, first of all, you see you cannot get B without A. So A will be the first thing to be computed. When A is computed, you just need y bar and x bar to compute B. Once you get your A and B, you substitute into your y is equal to ax plus b, and you have just discovered your regression line y on x. But we are going to be using calculator. We'll do that tomorrow for practice. I need you to, maybe I give you this tomorrow instead. Thank you very much.